Well, it's me again, I guess, for those of you who have seen the talk yesterday or half the talk that I gave with Isa. Today I'm with another topic and another team. We will talk about left bias. Although in the current political climate, it sounds like political cognitive bias, but it isn't. It is a very perceptual bias. We'll see it in a minute. And I have collaborated for this work over 2 other continents, so across 3 continents, including Europe, with Amy. Some of you will be very familiar with Amy. And we have Victoria and Serena from South Africa. Amy's in Melbourne. And Amy's students, Oscar and Tebogo from South Africa, which is a student with Victoria and Serena. So I'm grateful for their collaboration. They have given a lot of ideas and lots of effort in data collection that we still are analyzing. With that, I also would put the disclaimer that this is still a bit of a work in progress, but we are keen to share what we think of this phenomenon called left bias. Let's dive in. So I need to give you a little bit of a background first. So left bias is something to do with overhead illumination bias, or light from above prior. So there are different names for this phenomenon. So if you look at the circles in the row A, you will, if you see it like I do, you will see a bunch of convex disks, and the light is shining from above for these, and they are a bit lighter on the top, a little bit darker in the bottom. And then if you look at the B, you will see concave disks, and there you have the dark on the top and light in the bottom. And this then reverses again for C, and then again for D. This is because our minds are kind of statistical machines, so we tend to collect information over the course of our lives, arguably even evolutionary perspective, but I won't go in there. So if we learn, if we experience the world, always with the light coming from above, whether it's artificial light or natural light, we're used to seeing the light coming from above. So we have the sun above, the moon is above, our ceiling lights are above, our desk lamps are above. And eventually your mind makes sort of shortcuts and says, okay, light is always above, therefore shadows are always below. And if you confuse that, if you switch the shadow and light order, your mind makes a reversal of your 3D perception from shading. So if you rotate this, you change the right relationship between dark and light. And now you see the row A is actually at the end. So what used to be convex disks should become concave disks now, and B now becomes convex instead. So I go back and forth again just to demonstrate the effect and how it might change. This occurs, maybe you can also view them side by side. In this case, it's just one particular disk. This occurs in terrestrial imagery. So you can see if you rotate this one, for example, I like giving this example. Those of you who have seen this terrain reversal talks might have remembered that. I like saying that here you have a Swiss chocolate bar. When you rotate it, it becomes a Belgian waffle, as in the relationships between what is depression and what is a peak completely changes. It occurs also in some other examples, notoriously also in satellite images. So this is something, I mean, if you see the illusion like I do, if you follow the line here, I hope you can see my mouse, but I'm talking about the river that is actually flowing. It looks like it's flowing on top of a ridge. Logically, I know that it is not a ridge. I can see the snow on the floor. Also logically, I can conclude that this isn't really a correct image. And if I rotate it, for me, the spatial relations are more or less restored. Now the valley looks like a valley and river flows in the right way. This is provided by Google. You can, I mean, this is the original image. This is the rotated image. And we have done some prevalence study to see how that works. It works a lot more. So if the illusion persists, or it exists a lot more in northern hemisphere images, this is to do with the satellites' flying time. So they fly around 10 a.m. to avoid dark and fog and clouds and so on and so forth. And around this time, the alignment of Earth and the sun is so that the illumination is from the south for northern hemisphere, which means that the shadows are on the northern slopes, which is not what we expect to see. So here you can see in this first bar chart, about 40% of the time, people can tell that it's a valley, if it's a valley. So correction rate is so. If you rotate it, it goes up to 80% or so. In the southern hemisphere, it's reversed. When we present this, people come up with a hemisphere hypothesis, I would like to call. They ask if people who live in northern and southern hemispheres might have a difference between their perception of these overhead illumination bias, because the light is, after all, different in the southern hemisphere. So this is kind of the overhead illumination bias part. We did one more study where we can control the illumination angle better. So in the satellite images, you have very little control, or it's very expensive to try to do controlled satellite missions. So we have done terrain related thing, which you can easily do. We ask people if they see clearly a valley, if you look at the ABC, or if they see clearly a ridge or something in between. And we looked at, this is already published work, but I need to set the stage to get to the left bias. So we looked at all these angles going from 0 degrees in 22.5 degree steps. And we have done multiple terrains per illumination angle. And we asked people valley or ridge, valley or ridge. This is the outcome. So at the northern angles, you see the blue is correct. So people can pick up valleys as valleys and ridges as ridges. And the red is not good. Red is when they cannot identify it correctly. So you can see that there's a huge dominance on the southern angles where people cannot pick up the shapes correctly or landforms correctly. And the ambiguity in the middle is also quite interesting. And the northern, especially north-left images, that's where I'm coming to the point. So for us, the best in this study, the best angle was 337.5, and the northern 0 degree illumination was also quite good. It was better than the cartography convention. But it is, as you see in this range, it is between the 0 degrees to 315 or so. And after that, it actually starts, the number of errors grow quite considerably. But why is it left? So this is what's interesting. So overhead illumination, understood, the light is above, sun is above, but why should it be left? The dominant theory, which I think is has something to it, is that if you are a right-handed person, you are likely to align your body so that the light, if you're doing manual work, the light comes from the left so that there's no shade or shadow, rather, on the objects that you're manipulating or the text that you're trying to write. So you keep doing this, and again, since your mind is a statistical machine, it learns. So this is kind of the running theory about it, and this can be quantified. So we found a left bias at 13 degrees or so, 13.4 degrees, from the north to the northwest, and some others in the literature also documented that. So Gerard and et al. Found it at 22 degrees with 7 participants. They don't have information on handedness here because handedness matters. And we have on the 20, from Omajian and Goucher, we have a 24 degrees for left-handed participants and 27 degrees for right-handed. You see that for the left-handed, it's closer to the north, just a subtle, but a little bit. And then in a paper that is earlier in 1998, also not so many people, but they used handedness as a continuous covariance, and they found that for the right-handed, we have 23 degrees left bias, but for the left-handed, it's actually around 8 degrees, so it's closer to the north. Now, why should it be that left-handers have a left bias? They should have a right bias, right? If the idea is that you align yourself to make sure that the light comes correctly. A speculation, which I think is a reasonable one, is that left-handers live in a right-handers world, so everything is designed for right-handed people. For example, schools apparently design it so that you would put the windows would be on the left. So when you're designing classrooms, you would put the desks so that the light comes actually inside the class from the left side. So this kind of like architectural manipulations and all that probably affects left-handed people. So to be able to study this hemisphere hypothesis, we took this quadrant from north to northwest, so northwest angles, and we collected a bit more data from South Africa and Australia. So first to see if the results are replicated, but also to see if there's some differences potentially based on hemisphere. So in South Africa, about 87 persons participated. What is interesting is that the pattern remains. You see that the accuracy drops when you go towards west. I mean, now I'm going right to left, sorry for that, but you see the northern angles are north and northwest is high, and then it gets lower if you go towards the western angles. So overall pattern is essentially replicated, but north and northwest is identical in this case. In our original study, we had northwest superior to north. So there's something going on, perhaps. And then in Australia, this is unpublished and quick and dirty analysis. The data looks kind of like the South Africa as well, but even more pronounced. So here, the best angle is north. It's not even northwest at all, or they are not even identical. Here, with some disclaimer, again, that we didn't do proper statistical analysis yet. So these are basically summary statistics, but it looks interesting, right? So you might start thinking, okay, maybe there's something to this hemisphere hypothesis, but it's probably not the hemisphere. And I'll show you in a second why I think. I think that this north-side hypothesis is relatively weak. Personally, that's what my standpoint is. It's interesting to study, but I think it's not that clear. And handedness is, I think, the bigger deal. And well, why we already explained, there's evidence in literature for it. So we collected also more data in Switzerland. So look at this one. We have now 14 people in the participant pool from 35 people, and look at the numbers changing and compare this to other Swiss data, which is up here on the top of the G data set. This is for Gianna, so for the person who collected the data, and this is Julien's data set. This is two different people. So you see that this actually don't match. And if you look at what Gianna did, it looks similar to the South Africa and Australia data rather than Julien's data. But what is different is that in Julien's set, basically there is no left-handed people. And in Gianna's set, we particularly recruited left-handed people. It's not yet a balanced sample, and I think there's some outliers that we have to work with. This is, again, a descriptive statistics. And also here, there's more left-handed people, and here there's also more left-handed people. So initial analysis with the quick and dirty summaries suggests that maybe there's something going on with handedness, and less, I think it's less about the hemisphere. Maybe it's interesting to hear if you think differently. So I will finish the talk with more questions than answers. I would have to say that there's some signal, but we don't know exactly what the cause is. I think we need to do some more analysis first with the data that we have. And I think we should collect a bit more data, especially also going perhaps to the potential or possibility of a right bias, because now we cut the data from north to west quadrant, but what if some people actually have their best performance in the slightly right angles? We don't catch that at the moment. So basically we need to separate this hemisphere and handedness, but it looks like that there's something interesting to share with you soon. So I'm gonna close here. Thank you very much for your attention. If you have any questions, I'm happy to take them.
That was insane. That was great. Thank you so much, Arzu. And we've got actually some really good questions. We only have a minute though. Travis White asks, is there a bias difference between grayscale and color imagery?
Yes, it's actually quite interesting. We didn't do that for terrains, but we looked at that for satellite imagery. So we did a bunch of color satellite and black and white satellite. To some degree, to our surprise, and it's published work, I'm happy to pass that to Travis. A little bit to our surprise, the people did better with the gray than they did it with the color. And we speculated that it may be because the contrasts are important, and the gray has just the color satellite images may have just many different colors to work through. Maybe the complexity is higher, and in the gray there is enough contrast, and the contrast is perhaps very important. So this is how we speculated in the paper. There may be also more to research there, to be honest.
Beautiful. Well, thank you so much. There's a couple more questions in the Slack chat if you want to jump over there and answer them there. They're actually really good questions. Thank you.
It will be my pleasure. Thank you very much, John, and looking forward to the next talk.
Yeah, me too.